Hello everyone, I am Rishi Raghuvanshi. Welcome back to my YouTube channel. In this video, we discuss the topic regression modeling. Let's start. Regression modeling. Estimation and step-by-step techniques used in regression modeling. In this video, we will dive into regression modeling, a fundamental statistical technique for understanding relationship between variables. We will explore both estimation and step-wise methods, providing practical example using Python. First, introduction to regression analysis. Definition: regression analysis is used to determine the relationship between a dependent variable and one more independent variable. Now, types of regression. There are various types of regression, include linear, logistic, and polynomial regression, each suited for different data patterns. Now, applications. Regression is widely applied in various fields, include finance, healthcare, marketing, for prediction and analysis. Now, benefits. So many benefits of regression are regression modeling allow us to identify key factors influencing dependent variable and predict output and predict future outcomes. Let's see. In Python typically involve using libraries like scikit-learn, stats model, TensorFlow for machine learning based and statistical model. Below are step-by-step guide to implement regression modeling in Python using scikit-learn for a basic. Steps for regression modeling: import necessary libraries. We will need libraries for data manipulation, visualization, and model building. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt from sklearn.model selection, import train test split from sklearn linear model, import linear regression from sklearn matrix, import mean, so much. Now the code is uh, import numpy as np, import pandas as pd, import matplot.pyplot as plt. Now use from sklearn dot model selection, import train test split. Now use sklearn dot linear model, import linear regression. Now matrix, import mean, squared error, and rt square. To linear regression, we used model.fit xtrain ytrain. Now to calculate the mean square error, we use MSME, mean square error, y test, y prediction. Print f mean square method, MSC, calculate r square, r2 equal to r2 square, y test, y prediction. Print f r squared, r2. We have assumption and diagnostic of linear regression. First, we have linearity. In linearity, the relationship between variables should be linear, meaning straight line can best represent the relationship, means directly proportional variables. Independence. Data points should be independent of each other, meaning one point does not influence other. Next, normality. Residual difference between actual and predicted value should be normally distributed. Next, homoscedasticity. The variance of residuals should be constant across all values of the independent variable. Next, we have demonstrating of estimating model evolution using Python. We use the sklearn library, linear model, sklearn matrix, import mean square error. We use method model.fit to get the value. We use model.prediction, and we use mean square test for prediction and test. Next, interpretation of regression output and model fit. Coefficient. Regression coefficient quantify the relationship between independent and dependent variable. A positive coefficient indicates a positive relationship, while a negative coefficient indicates a negative relationship. P values. P values indicate the significance of each coefficient. Low P values, typically below 0.05, suggest that coefficient is statistically significant. Now, R square. R square measure the proportion of variance in the dependent variable explained by the independent variable. Suppose higher R squared value indicate a better model fit. Now we adjusted R square. Adjusted R square account for the number of independent variable penalizing models with too many variables. Introduction to stepwise regression. First, forward selection. Variables are added one at a time based on their significance. Next, backward elimination. Backward elimination, variables are removed one at a time based on their lack of significance. Next, step by regression. In step by regression, combines forward selection and backward elimination to find the optimal model. We have model selection and evolution metrics. We have mean square error, measure the average difference between predicted and actual value. We have mean absolute error, calculate the average absolute difference between predicted and actual value without their sign, positive or negative. Adjusted R square, account for the number of independent variable, penalizing models with too many variables. Now AIC, balance model fit with complexity, analyzing model with more parameters. Now we have key takeaways and conclusions from regression modeling are identifying relationship. Regression modeling help us to understand the relationship between variables. It is used to make prediction. We can use regression modeling to predict future outcomes based on historical data. Now we discuss improved decision making. Regression insight from informed decision making while highlighting key factors influencing outcomes. Now we have Python implementation. Python offers powerful libraries for regression analysis and making it versatile tool. I hope this video provide valuable insight into regression modeling. Ask in comment section. Stay tuned for upcoming videos. Thank you.